November 2024, the Pentagon releases a statement that makes headlines worldwide. The US Army declares the technology for all-electric battle tanks does not exist. They said it would take 1,200 gallons of diesel per hour to charge a single tank for just 15 minutes. Impossible, they claimed. The most technologically advanced military power in the world admits that electric tanks remain science fiction. But here's what they didn't mention. 82 years earlier, 1942, an Austrian engineer by the name of Ferdinand Porsche had already solved this problem. Not with lithium batteries, not with modern supercapacitors, but with German engineering from an era when tube radios were cutting edge. The name of this vehicle, VK4501, P. The P stood for Porsche. And what he built wasn't just a normal tank. It was the world's first hybrid electric battle tank. Two massive gas engines driving Siemens generators. These generators powered electric motors, which turned the tracks. No direct mechanical drive, pure electrical power transmission. The official story says Porsche's design lost out to Henschel's Tiger, but the truth is more complicated. Much more complicated. And what happened to those 91 Porsche Tiger chassis changed the war on the Eastern Front forever. Welcome to the forgotten history of German hybrid technology. But first, we need to understand why Ferdinand Porsche built a hybrid in the first place. The answer doesn't begin in 1942. It begins in 1900. Yes, 1900. When Porsche was just 27 years old, the Lohner Porsche Semper Vivus, the world's first hybrid vehicle. Porsche developed it in Vienna for the Lohner works. Wheel hub motors in the front, a gas engine that charged batteries, which then powered the electric motors. The concept was revolutionary. So revolutionary that Emperor Franz Joseph himself demanded a demonstration. Porsche was obsessed with electric drive, not because he was an environmental activist, but because he understood the fundamental advantages. Electric motors deliver maximum torque at 0 RPM, no transmission needed, no complicated power transfer, no power loss. Through mechanical friction, for 40 years, Porsche perfected this technology. In World War I, he built electric artillery tractors for the Austro-Hungarian army. In the 1920s, he developed hybrid race cars. In the 1930s, electric tractors. So when the Army Ordnance Office demanded a new heavy tank in 1941, Porsche knew exactly what he would build. Not a conventional tank with a transmission and drive shaft, but his vision of an electric fighting vehicle. 40 years of experience were finally about to be put to use. The specifications were extreme. 45 tons combat weight, an 80mm gun, front armor thick enough to stop any Allied tank at combat range, and a speed of at least 35 kilometers per hour. Porsche's solution was elegant in its complexity. Two Porsche Type 101 engines, each an air-cooled 10-cylinder, producing 315 horsepower, together 630 horsepower. These engines didn't drive the tracks. They powered Siemens Schuckert generators. Here's where it gets interesting. Each generator produced 500 kilovolt amperes of alternating current. This alternating current was routed to two Siemens electric motors. Each electric motor produced 230 kilowatts and drove one track. The transmission, non-existent, the complicated mechanical power transmission that plagued every other tank, eliminated. Instead, a control switch regulated the power distribution to the motors. Did the driver want to go left? Less power to the left motor, more to the right, elegant, precise, and surprisingly, reliable. But Porsche went even further. He installed regenerative braking, yes, 1942, the same technology that distinguishes every Tesla today. When braking, the electric motors became generators. The kinetic energy was recovered and converted into heat, keeping the crew warm in the Russian winter. Testing began in April 1942 at the Berka Proving Grounds in Thuringia. The VK 45.01P rolled for the first time. The test driver's reports were enthusiastic. The steering was more precise than any other heavy tank. No steering brakes that sapped power during cornering. No jerky gear changes, just smooth electrical power transmission. The tank responded like a sports car, a 57-ton sports car with an 88mm gun. But there were problems. The tank had become too heavy. Instead of 45 tons, it weighed 57. The amount of copper for the electrical systems was enormous. In a time when Germany needed every gram of copper for the war effort, this was critical. And then, the 20th of April, 1942, Hitler's birthday, a demonstration in Rastenburg, Porsche's hybrid versus Henschel's conventional Tiger. The history books know the result. Henschel won the contract, but here begins the real story. What happened to the 91 Porsche chassis that were already in production? Simply scrapping them was unthinkable. Too much work, too many resources, too much genius. Albert Speer had an idea that would change the war on the Eastern Front. In the autumn of 1942, the Alket factory in Berlin began the conversion. The Porsche Tiger hulls would become something entirely new. A tank destroyer, the heaviest tank destroyer in the world, armed with the longest and most armor-piercing anti-tank gun Germany had ever produced. The 80 mm Pak 43 L71, a weapon that could destroy any Allied tank at 3,000 meters. Mounted on Porsche's hybrid chassis, protected by 200 millimeters of frontal armor, the name Ferdinand, named after Ferdinand Porsche himself, later renamed Elefant, and the name was fitting. The vehicle weighed 65 tons. It was massive, it was slow, it was deadly. The electrical power transmission, which would have been problematic in a tank duel, became an advantage. Here, a tank destroyer doesn't need to maneuver like a tank. It takes up a position, it waits, it destroys at a distance. The precise steering allowed for minimal corrections when aiming. The regenerative braking kept the crew warm while they waited for targets for hours. In July of 1943, 90 Ferdinand tank destroyers rolled into Russia. Operation Citadel, the largest tank battle in history. Kursk, and here, Porsche's hybrid drive really showed what it could do. Near Poniri, in the northern sector of the battle, the 652nd Heavy Tank Destroyer Regiment fought 30 Ferdinands against hundreds of Soviet tanks and anti-tank gun emplacements. The results were devastating. For the Soviets, a single Ferdinand, commanded by Staff Sergeant Frederick Kopper, destroyed 22 Soviet tanks in a single day. The Soviet crews called these vehicles Stalnoy Slon, Steel Elephant. They quickly learned that frontal assaults were suicide. The 80 mm Pak 43 L71 gun penetrated every Soviet tank at any combat range. The 200 millimeters of frontal armor stopped everything the Soviets had, even the 76.2 mm field guns, which normally could crack any German tank, bounced off harmlessly. In the first week of Citadel, the Ferdinands destroyed over 300 Soviet tanks. The losses? 13 Ferdinands, but only 2 of those due to enemy action. The other 11 suffered from mines, engine failures, or accidental collisions in the terrain. The hybrid drive system proved to be robust, surprisingly robust. The Siemens electric motors kept running and running. No transmission failures, no clutch problems. The things that plagued other heavy tanks simply didn't exist on the Ferdinand, but the weaknesses also became apparent. No close-in defense, no machine gun. Soviet infantry quickly learned that they could attack the Ferdinands from the rear. Molotov cocktails on the engine deck, mines in front of the tracks. The crews were helpless against infantry that managed to get into their blind spots. After Kursk, the surviving Ferdinands were sent back to Germany for modifications. A hull machine gun was installed. The commander's cupola was improved. The new name, Elefant, was meant to mark the new beginning. But the real surprise came during the inspection of the electrical systems. After months of operation under extreme conditions, the Siemens generators and motors were in amazing condition, less wear than conventional transmissions. The electric drive that so many had dismissed as impractical proved itself better than expected. An engineer from Siemens wrote in his report, "The electric transmission shows less wear after 500 operating hours than a mechanical transmission after 200. The future of tank propulsion lies here." 1944. The Elephants fought in Italy, at Anzio, in the defense of the Gustav Line. The mountainous terrain and narrow roads were actually ideal for the heavy tank destroyer. The precision of the electric drive allowed for positional changes on roads that were too narrow for normal heavy tanks. Near Nettuno in February 1944, 4 Elephants held up an Allied advance for 2 days. They destroyed 11 Sherman tanks and several anti-tank guns, without any losses of their own. The American troops learned to fear and avoid these steel elephants, but their numbers dwindled. Each loss was irreplaceable. There was no replacement production. The 91 chassis from 1942 were all that Germany would ever have. A loss from an air raid here, 2 from mines there, 1 that sank in a river. When the Red Army reached Berlin in 1945, there were only 18 Elephants left. They fought to the end, in the streets of Zossen. Defending the Reich Chancellery, the last hybrid electric tanks in history fired their last shots in April 1945, but the story doesn't end here. After the war, the Allies captured several Elephants. The Soviets took 3 to Kubinka for analysis. The Americans took 2 to Aberdeen, and what they found astonished the engineers. The American reports from Aberdeen described the electric drive as surprisingly advanced. The concepts were ahead of those we are using in our own experimental vehicles. The hybrid concept deserves further investigation. But it wasn't further investigated. The war was over. Diesel was cheap. Nuclear power was the future. Who needed electric tanks? 70 years later, the situation has changed. Diesel is no longer cheap. Thermal imagers can detect engine heat signatures from miles away. An electric drive would be virtually invisible in combat. The advantages that Ferdinand Porsche recognized in 1942 are more relevant today than ever before. And yet, November 2024. The Pentagon says the technology doesn't exist. This is where it gets interesting. What's happening right now in the world of electric military vehicles? 2023, General Dynamics begins development of the M1E3 Abrams, a hybrid, diesel-electric. The official reasoning: improved fuel efficiency, reduced thermal signature, increased tactical flexibility. Exactly the advantages that Porsche recognized 82 years ago. Rheinmetall unveils the KF-51 Panther with an optional hybrid drive configuration. The German industry is returning to its roots, whether they know it or admit it. And then Tesla, Elon Musk's Tesla. The Cybertruck is being converted into the Sting APC, armored personnel carriers based on a civilian electric vehicle. The US State Department is involved. A $400 million controversy. But wait, there's a problem with the Pentagon's statement. A big problem. 1,200 gallons of diesel per hour to charge a tank for 15 minutes. That sounds impossible. And it is. But that's not the problem. The problem is the assumption. The assumption that an electric tank has to work like a Tesla. Charge, drive, charge. That's not what Porsche did. That's not what modern hybrid tanks would do. Porsche's design didn't need charging stations. It didn't need power from the grid. The gas engines generated the electricity directly. The tank was its own power plant. As long as there was fuel in the tank, the system ran. The M1E3 Abrams follows this exact concept. No charging at outlets. A diesel engine generates electricity. Electric motors drive the tracks. Batteries buffer peak loads. The system that Porsche invented in 1942. So, why the Pentagon statement? Why the claim that electric tanks are impossible? The answer lies in bureaucracy and in history. After World War II, a new arms race began. America versus the Soviet Union. Both sides developed new tanks. The M46 Patton, the M48, the M60, and finally, the M1 Abrams. All with conventional drivetrains, all with gears and turbines. The American defense industry specialized in gas turbines, General Dynamics, Honeywell, Textron. Billion-dollar industries built upon the AGT 1500 turbine, the engine of the M1 Abrams. A shift to electric drive wouldn't just require new technology. It would mean that decades of American engine development would become obsolete. Careers would end. Factories would close. Pensions would vanish. The Pentagon isn't just fighting against physical impossibility, it's fighting against institutional inertia. Germany doesn't have that inertia, not to the same extent. Rheinmetall is developing the KF-51 Panther with an open architecture. Various drive options are possible. Diesel, hybrid, maybe even fully electric in the future. The irony is delicious. Germany, where Ferdinand Porsche built the first hybrid tank in 1942, is the first Western nation to return to this technology, while America, the country that captured and analyzed Porsche's technology, claims it's impossible. But let's talk about China. Because China isn't claiming electric tanks are impossible, China is building them. The Type 99A2, China's most modern battle tank. The latest variant has a hybrid auxiliary power unit, not for main propulsion, but for running electronics and targeting systems when the main engine is shut down. Why is this important? Because modern tanks need more power than ever before. Thermal imagers, active protection systems, computerized fire control systems, electronic countermeasures. A modern tank is a rolling data center, and data centers need a lot of power. The M1 Abrams solves this problem by running its turbine constantly. Enormous fuel consumption, enormous heat signature, enormous logistical burden. A hybrid tank could lurk in ambush with its main engine off, batteries powering the electronics, no heat signature, no engine noise, just a steel predator waiting for its prey, just like the Ferdinand at Kursk. The technology Ferdinand Porsche developed in 1942 was ahead of its time, but not as far ahead as you might think. The basic principles are simple. An engine generates electricity. The electricity drives motors. No direct mechanical connection, just cables and controllers. The advances since then have been incremental. Better generators, more efficient motors, lighter cables, smarter controls. But the basic concept The concept Ferdinand Porsche developed in Vienna around 1900, that hasn't changed. What has changed is the electronics. Modern power electronics can handle currents that Siemens could never have managed in 1942. Silicon carbide transistors, gallium nitride switches, microprocessors making thousands of decisions per second, but the fundamentals are the same. Porsche knew in 1942 that electric drive was superior, maximum torque instantly, precise control. Fewer moving parts, less wear and tear. The question isn't whether electric tanks are possible. The question is why it's taken the world so long to accept it. And here's where we get back to Tesla, the Cybertruck, Elon Musk's controversial electric vehicle, angular, polarizing, and apparently interesting to the military. The Sting package, a retrofit kit that turns the Cybertruck into an armored personnel carrier, developed by a company called Unplugged Performance, and apparently supported by the US State Department. The controversy is real. $400 million is being discussed. For what exactly is unclear, but the implication is clear. The American military is interested in electric combat vehicles, very interested. At the same time, the Pentagon says the technology doesn't exist. The contradiction is obvious, but it makes sense when you understand the bureaucracy. Different departments, different budgets, different interests. The left hand doesn't know what the right hand is doing, or doesn't want to know. The Cybertruck as a military vehicle has obvious limitations. It's not armored enough for real combat. The range is limited. The infrastructure is lacking. But as a proof of concept, it's interesting. Here's a vehicle that shows that electric drive works for heavy vehicles. That shows that torque on demand isn't a dream. That shows that the technology exists. Contrary to Pentagon claims, history repeats itself. In 1942, the German Army Ordnance Office said that Porsche's electric drive was too complicated, too expensive, too much copper, impossible. They said they were wrong. The Elefant proved them wrong. Over 300 Soviet tanks proved them wrong. The Siemens motors that showed less wear after 500 hours than mechanical transmissions after 200 proved them wrong. In 2024, the Pentagon says that electric tanks are impossible. Too much power demand, no infrastructure. The technology doesn't exist. They will be wrong, just like the Army Ordnance Office in 1942. The question isn't if, but when and who. Will it be Germany with the KF-51 Panther, Rheinmetall's answer to the future? A tank designed for various drive options from the start. Will it be China with their hybrid auxiliary drives? And a willingness to invest in new technology regardless of old industrial interests? Will it be Israel with their history of improvisation and innovation? Even today, Israeli companies are developing electric drives for armored vehicles. Or will it ultimately be America, not through the Pentagon, but through private companies that see the obvious, through Tesla, through Rivian, through startups that don't even have names yet? Ferdinand Porsche would have appreciated the irony. He spent his life perfecting electric drive, from the Lohner Porsche Semper Vivus in 1900 to the VK45.01P in 1942. 42 years, 4 decades of innovation, and now, 82 years after the Porsche Tiger, the world is back at the same point, the same questions, the same resistances, the same false claims of impossibility. But this time, there's a difference. This time, there's evidence. Not just theoretical calculations, but vehicles on the road. Millions of electric vehicles proving that the technology works. The Ferdinand proved in 1943 at Kursk that hybrid drive systems function in combat under the most extreme conditions. At -30 degrees in winter, at +40 in summer, in the mud of the Rasputitsa, in the dust of the Ukrainian steppe. What worked then will work today. Better, more efficient, more reliable. History has proven Ferdinand Porsche right. It just took 82 years for the world to be ready to listen. But perhaps that is the lesson. Real innovation takes time, not because the technology isn't ready, but because the people aren't ready. Institutions aren't ready, industries aren't ready. Porsche was ready in 1942. The world was not. Today, the technology is ready, and so are we. The Pentagon says no. The technology doesn't exist. History says otherwise. And the next time you see a Tesla on the road, a Rivian, an electric Mercedes, remember Ferdinand Porsche. Remember the VK45-1P. Remember the steel elephants of Kursk. The future was invented 82 years ago. We just forgot to look. But wait, there's even more to this story. Much more. Because Ferdinand Porsche wasn't the only one working on electric tank drives in 1942. Just the most successful. The German arms industry was experimenting on several fronts simultaneously. The Maus, Panzerkampfwagen Beate Maus, the heaviest tank vehicle ever built, 188 tons. And guess what kind of drive system it had? Electric. Diesel electric, to be exact. Developed by whom? Ferdinand Porsche. A single Daimler-Benz MB509 engine generated power for a Siemens generator. The generator fed two electric motors that drove the massive tracks. The same principle as the Porsche Tiger, only bigger, much bigger. The Maus weighed as much as 3 Tigers combined. No bridge in Europe could support it. It had to cross rivers on the bottom, with a snorkel. A 188-ton submarine on tracks. But the electric drive worked. Despite the incredible weight, the Maus moved slowly, yes, 13 kilometers per hour max, but it moved. The electric motors delivered the enormous torque needed to set that mass in motion. 2 prototypes were built, both with Porsche's electric drive. Both were blown up by their crews in 1945 to prevent them from falling into Soviet hands. But the Soviets found the remains. They assembled the 2 destroyed vehicles into a functioning example. It stands today in the Kubinka Tank Museum outside of Moscow, a testament to Porsche's vision and to the madness of war. The technology of the Maus wasn't crazy, just the concept. A tank of that size made no tactical sense, but the drive was ingenious. Only electric motors could deliver the torque needed. Only electric power transmission could transfer the energy efficiently enough. And then there was the Rata, Landkreuzer P, 1,000 Rata, planned but never built, 1,000 tons. Yes, you heard that right, 1,000 tons, 8 ship diesel engines generating power for electric drives. The concept never made it past the drawing board, but it shows how convinced the German engineers were of electric drives. Why were they so convinced? The answer lies in physics. An electric motor has a flat torque curve from the first moment. At 0 revolutions, maximum torque, instantly. No run-up, no revving, no clutch slippage. An internal combustion engine must first build up speed. The power curve rises. The transmission must be adjusted. Gears must be shifted. Power is lost. For a heavy tank, this difference is critical. When starting on a hill, when turning in the mud, when accelerating suddenly in combat, electric motors react instantly. Internal combustion engines take time. The Tiger, with its Maybach engine and complex transmission, was notorious for transmission problems. The steering gears wore out quickly. The intermediate gears broke under stress. Every repair meant taking the whole tank apart. The Ferdinand didn't have these problems. No transmissions, no steering gears, just cables and motors. If something broke, you could replace it without disassembling the entire drivetrain. The maintenance reports from the war on the Eastern Front speak volumes. Tiger units constantly had tanks in repair, transmission problems, clutch problems, differential problems. The Ferdinand units did not have these entries. Their problems were of a different nature. Engine damage, yes, but no drive problems. The Soviets observed this carefully. After the war, they experimented with electric drives themselves. The Object 268, an experimental vehicle from the late 1940s, diesel-electric, inspired by captured German designs. But the Cold War changed priorities. Mass instead of quality became the Soviet doctrine. Simple T-54s and T-55s in vast numbers. No time for complicated electric motors. The German concepts were archived and forgotten. Something similar happened in the West. The American auto industry had just won World War II with conventional engines. Why change something that worked? Detroit built V8s. The military bought what Detroit built. Electric? That was something for milk floats and golf carts. This mentality lasted for decades. It persists in part to this day. But the world is changing. Fuel prices are rising. Thermal signatures are becoming a problem. Noise reduction is becoming important. The advantages that Porsche recognized in 1942 are suddenly becoming relevant. And here is the real scandal. These advantages were always known. The Aberdeen Proving Ground reports on the Ferdinand exist. They are publicly accessible. Anyone can read what the American engineers wrote in 1945. The hybrid concept deserves further investigation. The electric power transmission shows surprising advantages. The precision of the control surpasses mechanical systems. These words were written almost 80 years ago by American military engineers about German technology. And today, November 2024, the Pentagon says this technology doesn't exist. Either no one at the Pentagon is reading their own archives, or someone is deliberately lying. I'll leave it up to you to decide which option is more likely. German engineering from World War II is often reduced to rockets and jet fighters. The V2, the Me-262. Spectacular weapons that ignite the imagination. But the true revolution was more subtle. It lay in concepts like Ferdinand Porsche's electric drive, in ideas so far ahead of their time that the world didn't understand them until decades later. The VK45.01P was a failure by the standards of its time. It lost out to the Henschel Tiger. It was never mass-produced, but by the standards of history, it was a triumph of foresight, a triumph of engineering, a triumph of vision over conservatism. Ferdinand Porsche died in 1952. He didn't live to see the world slowly rediscover his ideas. He didn't see the first hybrid cars of the 1990s, the Teslas of the 2010s, the discussions about electric tanks today, but his legacy lives on. In every electric vehicle on the road, in every hybrid, in every discussion about the future of mobility, and soon, perhaps in tanks as well. Again, history moves in circles. What was old becomes new. What was forgotten is rediscovered. The ideas that Ferdinand Porsche developed over a century ago are finally finding their time. It's only taken 125 years, from the Lohner Porsche Semper Vivus in 1900 to the hybrid tanks of tomorrow. 4 generations of human innovation later, the world is realizing what an Austrian engineer always knew. Electric is superior. It always was. It always will be. The question is no longer if. The question is only when and who. And while the Pentagon claims the technology doesn't exist, engineers in Germany and China and Israel, and yes, even in America, are working on exactly this technology. In silence, without fanfare, without Pentagon press releases. The future is coming, whether the Pentagon wants it to or not. Ferdinand Porsche would have smiled. If you enjoyed this video, subscribe to the channel. Share it with someone who is interested in military history, and let me know in the comments. Did you know that Porsche was building hybrid tanks as early as 1942? Write Porsche if you already knew this story. Until next time.